ROBOTC. Once ROBOTC is open, I like to maximize the window so that I can take full advantage of my screen space. So I'm going to click this square here. And then I also usually close this start page just so I don't have anything in my window right here. All right, so there are some settings that you will need to do to ROBOTC in order to make it work with virtual worlds. First, you need to click the word robot, scroll down to platform type, and you want to choose Vex Robotics, Vex 2.0 Cortex. The next setting is click Robot again, scroll down to Platform Type again, and choose Natural Language Pltw. The final setting, click the word Robot, go down to Compiler Target, and select Virtual Worlds. Now we're ready to open up a new program. To start a new file, do not simply click this that says Open File, because that will take you to your documents, and we don't want to start from a already saved file. We need to start a new file. And you don't want to just click this file right here that says New File, because that just starts a brand new, completely blank file. We're going to start from a template that Mr. Reese has created for you to help you get started. So you want to click this word File, go down to Open Sample Program. Now to find the template that I've created for you, you'll need to click this little triangle right here and scroll down to Vex 2. Once that is open, use this bar right here or the track wheel on your mouse and scroll down until you find Pltw. Double click that to open it. Then you want this program called Pltw Template. You can either double click it or click the word Open. This is the Pltw template. So I've got several things on here to help you keep track of what you are working on. You can fill out as much of this as you feel necessary. You can leave it blank if you don't feel like you need it. Now we will set up the motors that we will use for virtual worlds. To do that, you can click this box right here that says Motor and Sensor Setup, or you can go to the word Robot, click it, scroll down and find Motors and Sensor Setup. They will both take you to the same place. Up here on these tabs, you want to find the one that says Motors. Click that. In virtual worlds, the motors for the robots are plugged into ports 2 and 3. Port 2 should be your right motor. So type in the name right motor. You want to select Vex 269 motor, and then you need to check this box for reversed, because when on the robot, the right motor is actually facing a different direction than the left motor. In port 3 name, we're going to put left motor. For type, we're going to again select Vex 269 motor, but we do not reverse the left motor. Click Apply, then click OK. Notice you now have information at the top of your program. These are called Pragma Statements, and they tell the robot where your motors are plugged in and what kind of motors you are using. The next step is I'm going to show you how to save a program to your H drive. It's important to save to your H drive, because then if something goes wrong with the computer you're currently working at, you'll still be able to access it from other computers in the district. Do not simply click this save button right here, because you don't know where that's going to save to. It might save to the C drive, it might save to the H drive, it might save to some folder in C drive that you don't even know about. So what you want to do in order to make sure you know where your program is saving is click the word File, scroll down to Save As, and click that. Now to find your H drive, it's going to be over here on the left side. Use this bar and scroll down. And yours probably looks like this, just says computer right here. Click this little triangle beside computer and these options will show up. You want this one that says H: at the end of it. Since I'm a teacher, mine says my name, but yours will say your student number and then H:. Click on that. Notice at the top now, it should say your student number here, and then H:. This is your H drive. So it's accessible by any computer that's connected to the Shawnee Mission District Internet. All right, I'm going to create a new folder to store my robotics programs in. That way I know where they're all at. So you simply click this wording right here, new folder, and this will appear. Call it what you want. I'm going to call mine robotics programs. And that way I know what's inside that folder. Now push your enter button and it will create the folder. Next, double click the folder that you just made to open it. Now you want to click on the file name box, and then the first activity we're going to work on is called basketball drills. So I'm going to change the name of my file to basketball drills. This way I know which lesson this program is for. Don't just save it as Pltw Template, and don't just call them program 1, program 2, because then you don't know what they are used for. Always use a name that you will remember for your program. Now I'm going to click save, and I have successfully saved my program to my H drive. Notice the name up here is now basketball drills, and it says it's saved to my H drive. If I hover the mouse over it, it brings up that H:, show that it's been saved to my H drive. Now I'm going to explain how to use the virtual worlds part of ROBOTC. Even though we don't have any code to make our robot move, I'm going to show you how the program itself works. Video 2 will cover how to write the actual code. If you click Download to Robot, virtual worlds will appear. Click this blue tab that says Log in locally, and then log in as guest. If you click the Robot tab, you can choose from all these different robots. I recommend either the Buggy Bot or the Mammal Bot. The Buggy Bot is smaller and moves very fast. The Mammal Bot is slower, is bigger, and moves a little bit slower. I like the Mammal Bot because I think the slower robot tends to be more accurate. Sometimes the Buggy Bot doesn't turn quite the right amount and causes inconsistencies in your program. You can experiment with these other robots if you want, but some of them you'll have to change your motor port numbers and it could get a little confusing. So I'm going to select Mammal Bot. Next, click on the Movement tab. This is where you will find your assignments for our class. You have to do the 4 activities that have stars next to them: basketball drills, Labyrinth challenge, Sentry Simulation 1, and Sumobot. If you click on the name of the activity, it'll bring up a picture to kind of show you what the activity is. Down here, specification document gives you more specific instructions on how to do this activity. But this one's pretty simple. You start here where the letter A is at. Your robot will drive this way, and you need to make it go past this line, either touch it or go past it, and then back to the beginning, and then go to the second line, and then back to the beginning, and then go all the way to the third line, and go back to the beginning. And when you do that successfully, a special window will appear that says you've completed the activity. At that point, you need to raise your hand and let Mr. Reese know so that he can check your name off. Since you're logging in as a guest, these activities will not be saved as you complete them. That's why Mr. Reese has a special checklist to keep track of what you have done and what you still have left to work on. Labyrinth challenge, you start here where the letter A is at, and you're going to drive this direction, and then you're going to turn and go up here, and then turn again, go this way, turn again, and go into your safe zone, which is the diagonal black lines. You cannot cross over any solid black line, and you cannot touch the edge of the field. For Sentry Simulation, you start here where the letter A is. You'll travel this direction, turn right, turn right, turn right, and end up where the letter A is at. On this one, you can actually cross over the black line, and you can touch the edge. You cannot touch the box in the middle, and you cannot drive off the edge. Sumobot is probably the easiest of all 4 activities. You start here where the letter A is at, and you need to drive into this collection of cans in the middle and push it all the way out of the circle. Just as a hint, use the mammal bot, at least for Sumobot, because the bigger robot will make it a lot easier to push these cans out of the circle. In order to receive credit for a completed activity, I need to watch the robot run the program that you've created. I cannot just simply see a filled-in star over here. I have to actually watch the robot run. All right, so we'll just start with basketball drills because that's the first activity. In order to start, you're going to click the green button down here that says Start Activity. And here is the basketball drills. Now there's a few different options you have here. Over here are camera angles. So camera 1, it says follows the robot. Camera 2 is a top-down view. And camera 3, it says, is a free movement. And if you just hover your mouse over camera 3, it tells you how you can control the camera. There's also a way to turn on your sensors down here, but those are not necessary for this activity. Once you have code in your code screen, in order to make your robot run it, you click this triangle right here, which means play. After you've run code, you always want to click this, which is the reset button, in order to make your robot go back to the beginning. Do not simply run your code from where your robot ends, or it will mess you up. And then at any point, you can click the house, and you can go work on a different activity, or you can choose a different robot. But I do not suggest choosing a different robot because, like I said, using a smaller robot will completely throw off your program. So it's best to stick with the same robot for every activity. Once you have finished all 4 of these starred activities, you can work on any of these other activities for fun, but they are not required for class. And under these other tabs are all kinds of other activities where you can practice your coding skills. This is the end of video 1. At this time, you should watch video 2 about how to actually write code for the ROBOTC program.